Good afternoon, ladies and gentlemen. My name is Mr. Royce, and today, period 6 on Monday for AP Stats, I will be your video sub. Now today, I'm in the building, but I'm a guest speaker in Melissa Feynman's World Religions class, so you have a live sub here in the room to satisfy all of your cravings for adult supervision. And I will be here providing you with satisfaction for all of your cravings for statistics knowledge. And my daughter is in the room with me today. Her name is Elia, and she will be my video daughter today. So, hello, Elia. And so occasionally she'll go and adjust the camera, and well, we'll see what happens. So thanks for coming today, video daughter. Okay. All right, so let's get started. On Friday, if I recall correctly, on Friday, we were doing this hot dog problem, and we had the probabilities of A, B, C, and D, and this is a two-way table. And in this two-way table, we connected it to a Venn diagram. So let's revisit that problem now. In fact, I want to start it over, so please take out, if you haven't already, take out a blank sheet of student supplied paper. And by the way, assignment 6.5 will in fact be due tomorrow. Hopefully video or live sub will collect your assignment 6.4, which is due today. Assignment 6.4, make sure you put it on the table on your way out of the room. You don't have to turn it in right now. So here we go. These numbers for A, B, C, and D were 0.1, 0.4, 0.35, and 0.15. So that will be our first example for today, except we're going to do something different with it. We're going to connect all four of those numbers to a tree diagram. And this is a stunning connection that I think you'll enjoy. So just write it down again. We had A, B, C, and D, 0.1, 0.4, 0.35, and 0.15. And we are going to end up using the row and the column totals. So we're going to go 0.5, 0.5. These totals are 0.55 and 0.45. On Friday of last week, we connected this to a Venn diagram. The Venn diagram connection was with, I could have declared that we were going to connect it to circles A and C, but the circles that we ended up using were, if I recall correctly, let me see, we got it right here, D and B were what we used, so I'm going to just recreate that. Those of you who missed it, if you were absent, the football, the DB football is, I must say in white. I was going over it in white. So let's go over this in red highlighter. The DB football was 0.15. So this is what we did on Friday. We put a 0.15 in the football. The D's that are not B were 0.35. The B's that were not D were 0.4. And outside the dividing cell was 0.1. Now, the question is, how could we take these same numbers that are in the two-way table and put them into a tree diagram? Now, which tree diagram, you might be asking? The tree diagram that I'd like you to form based on this two-way table is the tree diagram that starts out going either, we could go either A or B. Either A or B. And then if we have A, we're going to go to either C or D. And if we have B for the first choice, we're going to go to either C or D for the second choice. So now the question is, how do the numbers in this two-way table fit into a tree diagram? Notice how many numbers we need. 1, 2, 3, 4, 5, 6, and we need 4 leaves. So The probability of A is the column total for A, 0.45. The probability of B is the column total for B, 0.55. And by the way, I mean, those are pretty straightforward. The next parts of this tree diagram that are straightforward are the leaves, because think of it. A football is a leaf, is an intersection of a row and a column. So like for example, this is the BD leaf, so BD, that leaf is 0.15. So 0.15 for this leaf. How about this leaf? How about the AC leaf? What would that be? Raise your hand if you're reasonably sure you know what the AC leaf would be. All right, I'm having difficulty seeing whose hands are up, so just when I say go, I want you to say out loud and in unison what you think the value, the probability of A and C is. Ready? Go. Right? If you said A and C is 0.1, that's correct. Fill in the rest of the leaves on your own. Fill in the A and D leaf and the B and C leaf. When you're done, you can look up at the screen to see if we agree. All right, so A and D is 0.1. And C is 0.4. So now, on the tree diagram, we filled in these numbers. The hardest ones to fill in on the tree diagram are these lower branches. Well, this lower branch, algebraically, is the probability of C given A. And the probability of C given A, let's think about that. It's algebraically, it's whatever number you would need to multiply by 0.45 to get 0.1. But there's an easier way to see it in the tree diagram. What's the probability that you're in? I mean, this is tricky because we don't have C and A in this version of the Venn diagram. There's a lot of different Venn diagrams I could have drawn. Well, let's just get it right off the table. What is the probability that I'm in circle C, given that I'm in circle A? So let's shrink the universe down to the A subuniverse. This is the A subuniverse. It consists of 0.1 and 0.35. So the probability of being in circle C, given that I'm in the A subuniverse, would be 0.1 over 0.45. So it's 0.1 over 0.45, and that's an acceptable thing to write for now on this branch, 0.1 over 0.45. Try to do the other three branches. You can write them in fraction form like I did here. Try to fill in these other three branches on your own. Oh, that makes sense, okay. Okay, there's kind of a pattern to it. So here's how I'm thinking of it. To find the probability of D given A, that's D as in dog, given A, I want to know what's the probability I'm in circle D given that I'm in the A subuniverse. So the A subuniverse is here again, but now it's D given A, so it's 0.35 over 0.45. For this guy right here, which I'm going to write in green, I want to know the probability that I'm in circle C given that I'm in the B subuniverse. So this is the B subuniverse over here. The probability of C given B is 0.4 over 0.55. This last one is 0.15 over 0.55. So there we have it. We finally have taken a probability problem and connected the two-way table to the Venn diagram to the tree diagram. And in any given probability problem, if you can take, if they give you a two-way table, you know, go into a Venn diagram. But now you see how to take a, I mean, you can connect it that way. You can start at any one of these three and connect it to any of the other of these three in order to deepen your understanding. Now, you have a handout lesson plan. Your handout lesson plan for today should be up on the, well, I gave it to our live substitute, and she, I believe, has handed it out to you already. If not, you can hand it out now. Let's take a look at assignment 6. Or the handout lesson plan for assignment 6.5. And the lesson starts out with a global survey. By the way, first page is PowerPoint notes, and I posted the PowerPoint to the website. So you should have no problem identifying that. Here's the global survey problem, and let's read it together. The Marketing and Research Organization, GfK Custom Research North America, conducts a yearly survey on consumer attitudes worldwide. They collect demographic information on the roughly 1,500 respondents from each country that they survey. Here is a table showing the number of people with various levels of education in 5 countries. So I'm going to zoom in on this so you can see it really clearly when you're looking up at the screen. What is the probability that a person is from the United States? And this one comes right off of the table. It's not a big deal. Where is you? USA is right here. So we're going to take the 1557 from the USA divided by the total, and that's how we're getting your answer there. So those of you who are taking notes, if you forget how to take notes, I'm sure that Sam, Alex, and Jake, among others, would be providing you very positive role modeling on how to take notes. Again, thank you in advance, Sam, Alex, and Jake, for being such consistent role models on note-taking. 7690. So this is approximately 0.2025. Part B says, what's the probability that the person completed his or her education before college? So his or her education before college, what we're looking at here is before college would be either the some high school category, or it could be that they completed primary and less, and that or would be a union, which means we're going to be using the addition rule. So we'll take the probability of some high school plus probability of primary and less. And although, yeah, this is where we, in a Venn diagram, we realize that some high school and primary and less, in principle, if we don't actually think about it too much, we say, well, maybe there's some overlap there. So then we're going to subtract off the football, the probability that they finished high school, or they finished their education with some high school and primary or less. But that is impossible. It's one or the other. They are disjoint, which is why on the next line, this probability is going to be a 0. So if you look at the table, you'll see that some high school, if you take that category, and how am I going to read this here? Some high school is right here. So we're going to take our 4195 over the 7960 for that probability. And primary or less, we're taking 1161 over there. So this probability comes out pretty straightforward. We've got 4195 over 7690 plus 1161 over 7690. It's minus 0 again. So it comes out to, on your calculator, it would give you about 0.6965. Let's go on to part C. What's the probability that the person is from France or did some postgraduate study? Now, we've got the or comes right from the problem. And since it's an or, we're going to put in the union there. And this time, that union, probability A union B is probability of A plus probability of B minus any overlap. So I'm going to add these up, but subtract the overlap, because I want to count the football only once. If you study the table, you see the probability of France is 1539 over 7690. The probability of postgraduate is 379 over 7690. And the probability of the overlap is 69 over 7690. The calculator would give you an answer on that. That's wavy equals 0.2404. Now, the 69, probably both. That's both France and postgraduate. In case you're wondering where that comes from in the table, France is coming right across here. Postgraduate is right there, and the intersection, that 69 is where I came up with the 69 in that numerator. And finally, part D, what's the probability that the person is from France and finished only primary or less? So in the setup you have on the handout, we clearly are just going to write and in this blank, and the and is the intersection from the table. You can tell is 309 over 7690 to get wavy equal 0.2404. And now let's go on to our next example. Okay, we're on problem 11. And problem 11 is another look at this global survey. You have it printed on the top of your paper. Again, it's the same chart as we had on the previous problem. And this time part A reads, if we select a respondent at random, what's the probability that we choose a person from the United States who has done postgraduate study? So that's going to be the probability of USA. And what I'd like you to do is talk in your groups. Is that going to be an and, an or a given? Probably, just read it carefully. What's the probability we choose a person from the United States who has done postgraduate study? Try to come to a consensus in your groups. When you're done discussing it, look up front and see if we agree. Yeah, so the word and isn't actually in the problem, but you're responsible for inferring an and there. Now, I'd like you to work in your groups to figure out what the number is for that probability. Let's just go straight to the answer. And when you're done with that one, take a look up at the screen. Wavy equals on this would be 0.011. Let's go to part B. Among the respondents who have done postgraduate study, what's the probability that the person is from the United States? All right, in your groups, please choose what word goes in this blank. Is it and, or, given, or both? Yeah, that one's USA given postgraduate work. So now we have a chance to really look at this carefully. What's the probability of USA given postgraduate? Here, I like using the metaphor of the shrunken universe. Instead of the universe being the full universe of 7,690 survey respondents, because it's a given with a slash, we're going to shrink the universe down to the postgraduate sub-universe. So let's see if we can locate the postgraduate sub-universe in the two-way table. I found it. Here's the postgraduate sub-universe. So now instead of all 7,690, there's only 379 people in the universe. And we're going to calculate our probability accordingly. What's the probability that a randomly selected person is from the USA given that they're in the postgraduate sub-universe? So this is the point at which we can straightforwardly say 84 out of 379, which is 0.222 if you do the wavy equals. So we've got, answer on that one, 84 out of 379. Again, that's approximately 0.222. Let's go ahead and try part C on your own. I'm going to work part C up here. You work part C in your groups. Okay, the way I modeled it was the probability of being a postgraduate student given, or that they've done postgraduate study given that they're from the USA. So I'm going to shrink this down to the USA subuniverse. And here's my USA subuniverse of, there's 1557 respondents in the USA subuniverse. And we're going to go, what is it, probability of postgraduate. So where's, here it is. So 84 out of this subuniverse, 84 out of 1557 is what I'm going to go for. So we got 84 out of 1557. And by the way, the wavy equals calculated approximation on that is 0.054. Now, D and E, let's work on these together. D says, what's the probability that a respondent from China has only a primary level education? And actually, you know what, I think you can do these last two on your own. They're pretty straightforward. I think you got the idea. Go ahead and knock these out, and I'm going to put the answers on the board. You can check them. All right, it's the same football, it's the same intersection. It's primary intersect China or China intersect primary. Either way, that's 506 people in that. But it's just that you're in different subuniverses. That's why you divide by 1502 this time, 1161 that time, 0.436. Now let's go on to our last example, number 17. Okay, we are on our last example then, batteries, number 17. Now I think number 17, if I recall correctly, I gave you a lot of the answers on here. So anticipating that we might be right up at the end of the period, there's not a lot of work for you. Okay, so there's nothing for you to do taking notes. So let's just talk through this since the notes are already taken for you. Imagine a junk box in your room. It contains 12 old batteries. 5 of which are totally dead. Have you ever had a situation where you've got a whole bunch of batteries and you don't know which ones are good and which ones are dead? Has this ever happened to you? So you start picking batteries. What? I'm sorry?
It has to me.
It has to you?
Mm-hmm.
What do you do in those situations?
Just leave it to someone else.
Just leave it to someone else. Well, that's, you know, it's not a bad idea. Yeah. I mean, you start picking batteries one at a time and you test them. That's one thing you can do. You take them one at a time. Just take each battery and get a battery tester. We've got one of those in the garage. I'll have to show you that, Elias. So next time you can just use the battery tester.
Okay.
Now, what we're going to do is we're going to find the probability that the first 2 that you choose are good. Now, I like to think of this as a tree diagram. The first 2 are good. Now, since the batteries are not being replaced, use conditional probabilities throughout. Okay, so in a tree diagram, the first one is either good or a good complement. Complement means not good. And then we'll call this G1 or G1 complement. And then the second one is, I'll put this one in purple, G2 or G2 complement. Actually, I want to rewrite that a little bit. I'm going to make this tree diagram in one point, a little bit smaller. We're going to zoom in on this because this is a good review of conditional probability. The way to really fill this in and making it all red, actually I'm going to make it all blue because I think blue shows up a little bit better on the camera. Check this out. the lower branches in the tree diagram would be, I mean, yes, the outcome would be good to, this would be good to complement. This outcome would be good to complement. But the actual branch probabilities, this branch would be the probability of second one is good, given that the first one is good. And you would go through, likewise over here, this is the probability that the second one is good complement, which means not good, given that the first one is good complement or not good. So all of these branch probabilities would in fact be conditional probabilities. So what they're asking us for is the probability that the first one is good. That's the branch in the tree. This is the probability of G1 times the probability that the second one is good, given that the first one is good. So that's the probability of G2 given G1. So that's upper branch times lower branch equals total. Now the upper branch is 7 out of 12, but if the first one is good, then there's only 6 good ones left. So that's why the lower branch is 6 out of 11. Had the first one been not good, then that would have been 7 out of 11 for the first one. So this is branch times branch equals leaf is the setup there. So if you take a look at each one of these, I think you'll see that if you connect it to a tree diagram, you'll really have no trouble. Of course, some of them are complement counting probabilities, so think carefully about whether you need to subtract from one. But for this example, the notes are all there. I hope you find that helpful. Assignment 6.5 is due tomorrow. This concludes today's episode of Video Sub. See you Tuesday. You can tell me later if you want me to show it to the class.
Hi, Neal. This is my family, and this, yeah, just me. I wrote love on it because you know I really like doing double letters. Another drawing that I just did, and me and my brother Steven did tic-tac-toe up here. I wrote the alphabet, and this is explaining BFFC. You guys probably, well, whoever's listening to this probably knows what a BFF is. But a BFFC is a best friend and forever cousin. In my case, that would be better. Like, my BFFC is like a better friend to me than my BFF. So, it says, a BFFC is most likely a better friend than a BFF. In my case, Pazia is a better friend than me than anybody else in the entire world. She told me that she feels the same way, but you said her, me. And this is me, her. And this is one of my favorite colors. I just found it in the, yeah. And it says, I heart my daddy, I heart my mommy. This is what I'm hoping my daughter will be like, and she's going to be named Leslie. My first daughter's name is going to be Leslie, and so I'm going to name her Leslie, and this is what I'm hoping she'll be like. And this is, I love writing and drawing. This is something. This is the code word in my art class. Cold, completely. Oh, I forgot this one. I forgot what O stands for. Leave no way in darkly. And I heard my dad while he was doing his sub videotape. I just, write down B sub universe. And and this says I heart Hawaii, Gold Elia, daughter of Mr. Royce, and take that.
Cold? Are you cold?
No, this is cold stands for something in art class. Completely, I forgot what the O stands for. Leave no white and dark blue.
Okay. Hey, this is fantastic. Bye.